Hello everyone. Today we are going to discuss about private 5G and FWA fixed wireless access orchestration through Falcon Orchestrator. As part of it, we are going to discuss about private 5G and FWA network orchestration through Falcon Orchestrator, followed by orchestrator system architecture, orchestrator configuration, and demonstration. So basically, orchestrator for private 5G and FWA network comprises of two major components. One is known as overseator orchestrator and another one is gateway. The overseator orchestrator comprises of majorly three major components: lifecycle management, as part of which the network function deployment, the network function configuration. Basically, the day zero and day one can be uh, configured with the help of lifecycle management or managed as part of the lifecycle management. As part of the orchestration, it will be dealing with the subscriber configuration and sending it to the gateway. Service assurance, it comprises of two parts, that is basically the fault management, which includes the events and topology events and alarms from the network functions of the uh, private network platform. PM comprises of the statistics, those are going to be generated from the private network platform network functions towards the orchestrator. When we are talking about gateway, the gateway is basically sitting on the private network platform, which comprises of the 4G and 5G core network functions. It basically has the responsibility to register the private network platform with the orchestrator based on the mutual TLS certificates shared by the orchestrator during the uh, initial time of the installation of the gateway function into the private network platform. The private network platform is nothing but is going to manage the subscribers traffic towards the internet. As a whole, the whole orchestrator has the feature set of multi-branch support for an organization, subscriber configuration management and event management, performance management, and automation of whole D0, day 1 and day 2 operations. Now let us discuss in brief about the system architecture of the Falcon Orchestrator. As we have discussed, the orchestrator has two major components. One is the orchestrator, and another one is sitting on the private network platform, which is known as the gateway. So each of these orchestrator component that we are seeing over here is definitely going to have a counterpart in the gateway as well to facilitate various functionalities. Coming to the connection manager and connectivity controller, these are basically responsible for bootstrapping of the gateway with the orchestrator based upon the mutual TLS certificate shared earlier between the orchestrator and the gateway. Configuration management and subscriber management module. This is basically responsible for subscriber configuration using pull mechanism to the gateway from the orchestrator. Also, syncing of the configuration of the subscriber and other network function from the orchestrator to the gateway in a pull mechanism basis. Coming back to the PM and matrix D, these are basically responsible for sending the matrix data from the various network functions on the gateway or the private network platform to the orchestrator. Basically, matrix D performs periodic pull of stats from gateway to orchestrator. Similarly, PM on the orchestrator front is responsible for storing and retrieval of the stats at the orchestrator. Coming to the FM and event D, these components are basically responsible for sending all the events related to the alarm and the topology towards the orchestrator from the gateway. Let us discuss in brief about the fault management. It comprises of three major components: fluent bit, which is sitting on the gateway and interacting with the network functions, As and when the network functions create any events, those will be combined and sent by the fluent bit to the fluent D component on the orchestrator. In turn, the fluent D component sends all those combines all those events and sends it to the to the Elasticsearch where the data is stored, and the data stored in the or the events stored in the Elasticsearch are retrieved with the help of REST APIs exposed at the orchestrator. Basically, on the NMS, using this REST APIs, we can fetch all the Elasticsearch, all the events from the Elasticsearch and show it on the NMS. Okay, let us now discuss about the performance management, which comprises of two major components: Prometheus exporter on the gateway, which is responsible for fetching all the matrices produced by the network functions towards the Prometheus over a secured channel. Prometheus basically stores this matrix or counters and exposes a set of APIs with the help of which we can fetch this matrix or counters and showcase it in the NMS. So let us now go through the orchestrator configuration through the demonstration. As part of it, we are going to showcase how do we configure an organization in the orchestrator. Along with the organization, we are going to configure the network. Inside the network, we can configure multiple gateways. Those gateways we are going to register with the orchestrator. After registration of the gateway, we are going to configure the APN and policies and the corresponding subscribers. Together, we are going to push it to the gateway, and we are going to see the demonstration of the subscriber being reached at the gateway network functions. And after configuring the network, under the network, we can configure multiple subscribers, corresponding APNs and policies. So let us start. So we are going to log into the host portal using the email and the password. Here you can see there is one feature known as add organization, with the help of which we are going to configure the organization to the host portal. So here we can see that we have already configured an organization known as Veltris, under which the accessible network is test. And here is the URL to the organization portal, Veltris organization portal. So by clicking this, we are going to switch over to the Veltris organization portal. Here also we are going to log into the organization portal using the email and the password. Under this organization, we are going to set up a network using the add network feature. Here we are going to create the network known as net2. After creating the network, we can see in the host portal that the organization is associated with the network net2. Now let us switch back to the network organization portal network, and under which we are going to add or set up a gateway using the add gateway feature. As part of the gateway addition or gateway registration to the organization's network net2, we are going to provide a gateway name followed by a gateway ID, and there is a hardware UUID, and there is a challenge key. So the hardware UUID and the challenge key are the most important thing, which uniquely identifies the gateway with the network basically. The hardware UUID and the challenge key are generated at the gateway using the utility known as show gateway information. Here you can see we have one unique hardware UUID of 64 bytes. We have a challenge key. This hardware ID and challenge key will be an input for registration or addition of the gateway with the network. Part of the gateway addition, we have to configure various component of the gateway, that is the corresponding RAN related configuration, the corresponding APN related resources, those are associated with the gateway, etc. Once we add the gateway status or the health status will be showing as bad, is showing as bad. That is because it is not yet registered with the orchestrator. So in order to register with the orchestrator, we need to use the command check-in CLI to register the gateway with the orchestrator using the already shared mutual TLS based certificate from the orchestrator. So here we can see that the check-in CLI tests the TCP connection with the orchestrator and then exchanges the TCP certificate, TLS certificates, which are going to be verified by the orchestrator. And once the verification is successful, the orchestrator is going to share the corresponding gateway certificate and the gateway key to the gateway. After this, we can see the health status of the gateway at the orchestrator as good. Now that the gateway is added, let us configure few of the policies and the APNs which we are going to associate with the subscriber later. So our policy is added. We are going to add a APN. Once our APN addition and policy addition is successful, we can add subscribers using the add subscriber feature. As part of the addition of the subscriber, we are going to provide the IMSI of the subscriber followed by the auth key and OPC key, and we are going to associate the corresponding APN and policies with the subscriber. Once we add the subscriber would be visible at the gateway through the sync up mechanism that is set up at the gateway, which is going to sync up with the orchestrator on a regular basis to fetch the subscriber and other configuration information. So here we can see that as the subscriber is created, this subscriber is associated with an APN and a policy and the corresponding key and OPC values. At the gateway, we are going to check the are added at the orchestrator and are reflected at the gateway. So we can see that we have added the subscriber with IMSI ending at 7890, and that is added at the orchestrator and now visible at the gateway. We can check the details of the subscriber that get added at the gateway by using the command subscriber cli.py get imc. Here we can see that whatever APN and the policies those are configured are visible for the subscriber. So apart from checking the subscriber information using the subscriber CLI, we can also check through the logs of the subscriber coming in the subscriber DB module of the gateway, which is an equivalent of the UDM module in the 3GPP component. Here we can see through the logs that the subscriber is added to the gateway with the corresponding APN and policies and other information. So here you can see the corresponding IMSI and the APN, all those things are configured to the subscriber. So as the subscriber is added and the network functions are up and running, the gateway is registered. Now the subscriber is added. Let us go through the events and topology information. Those are being pushed from the gateway to the orchestrator. Here you can see in the events section, there are many network function related events. Those are coming in. So this one of them is the port status, where we can see the all the interface status of the gateway. We can see that various type of events are visible on the NMS dashboard of the event, and each of these event are categorized based upon the hardware ID, because of which it is going to uniquely identify an event from the gateway perspective. So apart from the events, we can also check the statistics with respect to the network functions and the CPU usage of the network function in the gateway, and all other statistics through the Grafana dashboard, which is basically sends a query to the Prometheus that is configured on the orchestrator to get the information with respect to the gateway and the internals of the CPU and memory. It also fetches the subscriber statistics, which is with respect to the input and output bytes, the data consumed by the subscriber. So here we can see that physical memory available, percentage, virtual memory, percentage. All these graphs are well drawn by taking the input from the Prometheus. All the events and statistics, all the subscriber information that we are seeing through the NMS dashboard can also be viewed through the Swagger API. So the Falcon Orchestrator provides us Swagger API access, with the help of which we can uh, retrieve all the information with respect to the subscriber and the network functions that we have configured earlier. Here is the Prometheus URL, which is part of the Falcon Orchestrator. All the counters and statistics related to the network functions can be observed from this Prometheus query window. We can query for any of the counters those are sent by the gateway to the Prometheus, and then get the value of it in a given point of time. We can also generate graphs of those counters from this Prometheus graph dashboard. So we are now querying for the check-in status counter of the gateway. Here is the number of gateways those are registered with the orchestrator that can be observed. The count is one. That means only one gateway has been registered with the orchestrator, whose graph also can be seen over here. That at a particular given point of time, the counter has shoot up to one. That means one gateway is registered with the orchestrator. Similarly, the CPU percentage also can be seen for the various network functions as part of the till now we have added only a single subscriber to the gateway through the orchestrator. Now let us add a batch of subscribers, showcasing the batch processing capability of the orchestrator, with the help of which we can add a batch of subscribers, and those can be visible at the gateway level without any hassle. So for that reason, we need to upload a CSV formatted file where we have inputs of multiple subscribers. So we can see that all the subscribers are added successfully to the orchestrator, and same can be observed at the gateway subscribers. Those are same number, the same subscribers that we have added to the orchestrator or to the gateway can be fetched using the Swagger APIs as well. With this, we have come to an end of our Falcon Orchestrator demonstration for subscriber, event, fault management, and other services. Thank you very much for your time. Feel free to ask questions in comment section. So we can observe that all the subscribers that we have added through the orchestrator are now visible at the gateway.